should check. But you know for sure x equals 0 will not change signs. Concave down, that's f double prime negative. So I'm going to make an f double prime number line. I've got x equals 0, 1/2, and 3. But 3 has a even exponent, so it's not going to change signs. So I'm not super worried about it, because whatever happens after 1/2, that will be the sign forever. Now I just plug in, if I have -1, that would be 3 times -1, which is negative. -1, yep, that's negative. And then this is going to be positive no matter what, so then that will be positive. If I plug in like 1/4, 3 times 1/4 is positive. 2 times 1/4 would be 1/2. 1/2 minus 1 is definitely negative. And then this is positive no matter what, so that's negative. And then, no, it's going to flip signs. I don't know why I did that, because actually once I have 1, I know these flip signs and this doesn't. So it's concave down only from 0 to 1/2. Decreasing is going to need an f prime number line, so I've got to find f prime. Let's rewrite this. That's x squared minus 2x to the -1. So that's f. Find f prime is 2x. Bring this down. That's positive 2, x to the -2. So that's 2x plus 2 over x squared. Then I need to set equal to 0. I also want to check where it's undefined, so that's x equals 0. Let's multiply everything by x squared. So still 0, because x squared times 0 is 0. That would be 2x cubed plus 2. Subtract over. Divide by -1. The cube root of -1 is -1. This is not a plus or minus, because positive 1 cubed is positive 1, not -1. So it has to be -1. So these are my two critical values. And now I have to plug in. Let's just plug in 3. So that would be 2 times 3 plus 2 over 9. That's definitely positive. If I plug in, I actually know that this one's not going to change because it's x squared on the bottom right here, but let's just check in case it got confusing for you guys, because it doesn't look like the regular factors. Let's check like -1/2. You have 2 times -1/2 plus 2 over -1/2 squared. So this is going to be -1 plus. This is going to become positive because it's getting squared, and it's going to be a big number because you have 2 divided by 1/4, which is 8. So see how this is going to be positive right here? And then if I plug in like -3, then it would be 2 times -3 plus 2 over 9. This is -6 plus a decimal. That will definitely be negative here. So it's decreasing less than -1, and that's it. Less than -1. This is positive here and here. Concave down is where f double prime is negative, but I was given f primes. That means I'm going to have to find the derivative. So I'm going to use product rule. U is x plus 1 cubed. U prime will be 3x plus 1 squared. Derivative on the inside will be just 1. V is x minus 4. Derivative of that is just 1. So u prime v plus uv prime. 3x plus 1 squared, x minus 4 plus x plus 1 cubed times 1. Set that equal to 0 because that's my f prime. And I'm trying to find, oh, so this is my f double prime. And I'm trying to find where it equals 0. So I'm going to factor out. I see x plus 1 in both of them. This has a square, this has a cubed. So x plus 1 squared is common to both of them. When I pull up the x plus 1 squared, I'm left with 3x minus 4. When I pull the x plus 1 squared, I'm left with 1 power of x plus 1 times 1, doesn't really matter. Distribute that, that's 3x minus 12 plus x plus 1, which is 4x minus 11. And then this is still there. So I've got two factors. I've got x equals -1 and add 11 divided by 4, 11/4. Make your number line, -1 and 11/4. X equals -1 is getting squared, so I know it's not going to change signs there, so I only really need to check one side of this. So let's say I plugged in 0. That's positive. 0 minus 11 is negative, and then after that will be positive. This one doesn't change signs, so it's still negative. So concave down for x less than 11/4. Given the derivative of f prime, which of the following is true? So point of inflection is f prime changes increasings. At -1, nope, it's changing from negative to positive. That just means a minimum, not a point of inflection. F decreasing is f prime negative, so I want negative values from -7 to -3. No, that is f prime decreasing, which is not f decreasing, right? F decreasing is right here because f prime negative. Local maximum is f prime positive to negative. At 5, it is positive and still positive. It's not actually changing, so that's not a local max. And point of inflection, we said was changing increasings at x equals 5. Yes, it's changing from, or not it, f prime is changing from decreasing to increasing, so that was true. Concave up, I want to let f double prime positive. I'm going to make my f double prime number line. So first, I guess g, whatever. Find g prime. Let's rewrite this. We do not need to use quotient rule because I actually only have one factor, right? This is just -3x plus 1 to the -1 power. And that's a lot easier than doing low d high minus high d low. You'll get the same thing because the top is just -3, so the derivative is 0, but a lot more work than you need to do. So bring the power down. That's 3x plus 2 to the -2. Don't stop there because I actually want second derivative, so just take the derivative again. Bring this down. This is -6x plus 2 to the -3. So that's -6 over x plus 2 cubed. Nothing is going to make this 0, but it will have be undefined at -2. So then check -2. If I plug in 0, 0's on this side. If I plug in 0, that's going to be -6 over 8, which is definitely negative, and then this will flip signs because this is a cubed, which is a odd exponent, so we'll flip signs. So it is concave up, x less than 2, because g double prime positive. Okay, sketching what f prime and f double prime look like on a graph of f. So I want to translate these into f. So f prime positive means f is increasing, and f double prime positive means concave up, increasing and concave down. This is decreasing, concave up. This is decreasing and concave down. So I literally drew concave up and concave down, and then this part is decreasing, this part is decreasing, and then this one is increasing, and last color, increasing. So this is concave up, so f double prime positive, f double prime positive, concave down, f double prime negative, f double prime negative. This part is decreasing, f prime negative, decreasing, f prime negative, increasing, f prime positive, increasing, f prime positive. So if I want increasing concave up, that's this, the pink side, so something like that. If I want increasing concave down, this is concave down, the increasing part looks like this. Decreasing concave up, the decreasing part is here, and decreasing concave down, decreasing looks like this. Here I have f, which the following could be f prime, so f starts increasing, then decreasing, then increasing, which means f prime will be positive, negative, positive. So I want to start positive, then be negative, then be positive, check. Start positive, never goes negative, wrong. This starts negative, positive, wrong. Positive, negative, positive, check. So between these two, now I also have to check concavity. So first it's concave down, and then it's concave up after. That means f prime should be decreasing, and then it should be increasing after. So I want just this graph to be going decreasing, then increasing, which decreasing, then increasing, it checks. Whereas this one is increasing, decreasing, increasing, decreasing, which would mean like concave up, down, whatever. Alright, I want a graph that is continuous everywhere, so no holes, no jumps, no holes or jumps. But I want it not differentiable, so maybe like a cusp, something like this at 2. And then I want dy dx, which is just y prime, or the slope, to be, so y prime less than 0, so that's negative, which means decreasing. So I want y decreasing for all values. So I want it to be continuous, no jumps or holes, But at x equals 2, I want to get something funky where you couldn't take the derivative, but I still want it decreasing. So I want something like this. So I should have a negative slope everywhere, but okay, I guess that wasn't dramatic. Maybe like that. So definitely could not take the derivative right here because it kind of has a weird turn, but it's still a negative slope everywhere. And I don't want to have something like this because then it's not continuous. There's a lot of ways you could do this. As long as you have it decreasing everywhere, as long as you never have like a hole or a jump, and as long as it has like a weird turn right there, then you're good.